Hello, welcome to my Algebra 1 review series. This video covers Chapter 10, Section 3, titled Finding and Estimating Square Roots. By the end of this video, you will have reviewed recent lessons describing the methods of finding and estimating square roots. You will simplify square root expressions. You'll be looking at rational and irrational square roots, and you'll be estimating and using square roots. Finally, you'll have reviewed the solving of a real-world problem. If you'd like me to cover any of these topics in greater detail, please leave a request in the comment section below. Please subscribe to this channel if you find this video to be helpful. Thank you. Okay, before getting started, let's look at some definitions. And we'll see them again later in the video, but I'll just state them in the beginning so they're fresh in our minds. A square root. The number a is the square root of b if a squared is equal to b. I'll say it again. The number a is the square root of b if a squared is equal to b. A principal square root, a radical symbol, the symbol of the square root sign, you see that it's right here, the radical symbol, indicates square root. The expression, the square root of 16, means the positive or principal square root of 16. A negative square root, the expression minus or negative square root of 16, means the negative square root of 16. The radicand, the expression under the radical sign, is the radicand. So if this is the radical sign, the number here, a, is the radicand. Okay? And the squares of integers are called perfect squares. So if you square 2, you get a 4, and that is a perfect square. That's what they're talking about. The squares of integers are called perfect squares. Okay, objective 1, finding square roots. The diagram at the right shows the relationship between squares and square roots. Every positive number has 2 square roots. So you see here, looking at the diagram right here, it says 4 squared is equal to 16. And negative 4 squared is equal to 16. And the square root of 16, therefore, is plus and minus 4. Okay? The definition, square root. We've done this before. The number a is the square root of b if a squared is equal to b. Okay, so that's like saying it right here. If we look here, the number a is the square root right here, the 4. How about this with the square root? 4 right here, 4 right there. The square root of b, which is 16, if a squared, the 4 squared, gives you 16, and that's what we're talking about here. So it says here, in the example, a squared is equal to 16, and 4 squared is equal to 16, and negative 4 squared is equal to 16. So 4 and negative 4 are square roots of 16. A radical symbol, which we've seen it again. Now here it is, another picture of it. A radical symbol indicates square root. The expression, the square root of 16, means the positive or principal square root of 16. The expression negative or minus the square root of 16 means the negative square root of 16. The expression under the radical sign is the radicand. We know that. And also pay attention here. When we're talking about negative square root, the negative sign is outside of the radicand, the radical symbol. It's not under the radical. With the negative 16 is not inside. It's outside the radical symbol. Okay? Okay. Example 1. Simplify square root expressions. Simplify each expression. So let's look at, there are 5 of them here. A, what is the square root, of 64? The square root of 64 is 8. 8 times 8 is 64. It's a positive square root. Okay? How about negative square root of 100? That is negative 10. The negative is outside. Square root of 100 is 10, so it's negative 100. This is the negative square root of 100. Okay? Plus and minus the square root of 9/16 is equal to plus and minus. The plus and minus is outside of the radical. The plus and minus 3/4. 3/4 is the square root of 9/16. Take the square of the 9 is 3. The square root of 9 is 3. The square root of 16 is 4. The square roots 3/4 and negative 3/4. That's why you have the plus and minus right there. How about, what is plus and minus the square root of 0? It equals 0. And there's only one square root of 0. It's 0 right here. And finally, what is the square root of negative 16? Well, it's undefined. And that's the case we were speaking of a little earlier when I was mentioning it. You cannot take the square root of a negative number because there's no number in the world that you can't say negative 1 squared or negative 2 squared is going to give you a negative anything. Or you know what I'm saying? The square root of, you understand that? So you can't square any number that's negative and have it return a negative number when you take the square root of it. Okay? Okay, example 1, check your understanding. You know, stop the video and try these. Come on back and we'll do them together. Okay, assuming you've stopped it, you've worked them, you'll come back. Let's go ahead and move forward on them. Problem A, what is the square root of 49? Well, the square root of 49 is what number times itself gives us 49. The square root of 49 is 7. 7 times 7 is 49. How about plus and minus the square root of 36? What is this plus or minus the square root of 36? Well, it's plus or minus 6. 6 times 6 is 36. The plus or minus is outside the radical, so we can say plus or minus. Okay? How about, what is the negative square root of 121? Well, what times itself gives you 121? The answer is 11. 11 times 11 is 121. And it's negative, so it's negative 11. And finally, on D, the square root of 1/25 is what? The square root of 1/25 is the square root of 1. I'll do it. The square root of 1 over the square root of 25. And that is equal to 1. The square root of 1 is 1. The square root of 25 is 5. The answer is 1/5. Okay, example 2, rational and irrational square roots. Some square roots are rational numbers and some are irrational numbers. And an irrational number is a number that you cannot completely define what the number is. If it's a fraction, it'll have a fraction base to it, like 1 point something, 1.629 something, and that point value, the fractional value, will go on forever. It will never stop and define as any one thing that you can create by dividing two integers to get that value. You can never do it. That's irrational, and that's why they call it irrational. You can never know the true answer. So let's look at a few. It says rational numbers. The square root of 100 is 10. 10 times 10 is 100. It's exactly 10. How about the square root of 0.36? Plus or minus the square root of 0.36. It's plus or minus 0.6, because 0.6 times 0.6 is 0.36. And it's plus or minus. How about the square root of 16 over 121? That is equal to 4 divided by 11. Those are all rational numbers. They're perfectly defined. That number is 4 divided by 11. Okay? So, how about irrational numbers? The square root of 10 is irrational. Look at that, because it's approximately, if you run it through your calculator, 3.162277766, and it goes on and on and on and on and on, and it never ends. Irrational. How about the square root of 1/7? It's approximately equal to, If you do run your calculator, 0.377964473, and on and on and on and on. And you cannot define what it is. Okay? So tell whether each of these expressions is rational or irrational as we go down. So that's what it's asking. So what is plus or minus the square root of 81 is equal to plus or minus 9. 9 times 9 is 81. It's rational. You see I've got the answer here already. How about negative square root of 1.44? Well, that's negative 1.2, because 1.2 times 1.2 is 1.44. And that is rational. It's an exact answer. How about the negative square root of 5? The square root of 5 is, so it would be approximately negative 2.23606797, on and on and on. That is irrational. You cannot ever know the true value of that number. You can only approximate the value of that number. You can get very, very, very close, but it's still in a very, very, very close approximation. How about the square root of 4 divided by 9? That's 2 divided by 3. Very rational. And 1/3. The square root of 1/3 is approximately 0.577350026 forever. And that's irrational. Okay, example 2, check your understanding. So they want you to go off and want you to look at these and see if you can tell whether they're rational or irrational expressions. I'll wait. Okay, I assume you stopped, tried them, and you're back. So let's do it. What is the square root of 8? What times what will give you 8? So that you can take the square root of it and get that number back. Is there any number? Is this rational or irrational? Well, if you run on your calculator, you're going to find out that the square root of 8 is not defined, okay? You can't do that. It'll go on forever. So this is irrational. Irrational. How about B? Plus or minus the square root of 225. Is there a value? Is there a square root of 225? And if you square it, that number, do you get 225 back? Plus or minus, what is the answer to that? It's plus or minus 15. And this is rational. Okay, rational. How about this negative square root of 75? Well, I can tell you right now that there are no two numbers that you can multiply together and get 75. Okay. I mean, same numbers. There's numbers you can get 75 with, 5 and 15. But I'm talking about the same number squared. And whether it's negative or not is irrelevant. It is irrational. Okay? And how about the square root of 1/4? The square root of 1/4 is equal to what? Anybody know? I'm sure you do. 1/2. And 1/2 times 1/2 is 1/4. And this is therefore rational. Good job. Okay, so in objective 2, estimating and using square roots, we're going to talk about perfect squares. What is a perfect square? The squares of integers, 2, 3, 4, 5, 6, okay, are called perfect squares. So consecutive integers, 1, 2, 3, 4, 5, 6, 7, 8, I've got them written out here. Where's my pen? There it is. 1 through 8 goes on forever. Integers go forever. The consecutive perfect squares are 1, 4, 9, 16, because it's the square. 25 squared is 25, 6 squared is 36, 7 squared is 49, 8 squared is 64, 4 squared is 16, 3 squared is 9, 2 squared is 4, 1 squared is 1. We can go on and on and on. 9 squared is 81, 10 squared is 100. They're all considered perfect squares. That's because they're all squares of integers. There's no fraction ever involved with this. No decimal point values. You can estimate square roots by using perfect squares. So we're going to look at that momentarily here. Okay, estimating square roots. Example 3. Estimate between what two consecutive integers is the square root of 14.52? The square root of 14.52. Between what two integers? Well, what you're going to do then, you can look and think about your perfect squares, okay? And we can say, we can say that the square root of 9, where'd my pen go again? There it is, here it is. The square root of 9, which is 3, is less than the square root of 14, which is less than the square root of 16. Why? Because 16 is larger than 14.52, and 9 is less than 14.52, and these numbers are consecutive. 9 is 3 squared, 16 is 4 squared, so 3 and 4. Here's our two numbers, 3 and 4. So the square root of 14.52 is somewhere between 3 and 4. The square root of 9 and 16 are 3 and 9 respectively, and therefore the square root of 14.52 is between 3 and 4. So you can estimate it and say, yeah, it's somewhere between 3 and 4. Okay. Okay, an example. Check your understanding. They want you to go off and look at between what two integers is negative 105, the square root of 105. So go off and do it. When you get back, we'll do it together. Okay, I'll assume you're back now. So let's think about this. It's square root, it's negative. You could do the same thing with positive right now just to get the answers. But we're looking at the square root of 105. Okay, and that fits between the square root of 100, which is 10, right? And the square root of 121, which is 11. 11 and 10. So somewhere 105 is between these two numbers, and these are consecutive. So it's negative, of course. So that means that the number you're looking for is somewhere between negative 11 and negative 10. The square root of 105, negative 105 is somewhere between negative 11 and negative 10. Okay? Good job. Okay, example 4, approximating the square root with a calculator. It's pretty simple. I mean, there's nothing difficult about this. You can find the approximate. That's the key word here. This is the approximate. Always remember that. Generally, approximate value of a square root using a calculator. So it says here, calculator, find the square root of 14.52 to the nearest 100th. Okay, well, if you put the square root of 14.52 into your calculator, you're going to get, and I wrote approximately right here, you're going to get 3.810511777 something on and on and on. It's an approximate value because they never can stop and say, okay, right here equals this value. It goes on forever. So that means it's irrational for sure. But if we look at it, we're going to say we're going to want it to the nearest 100th. So we're going to take the accuracy to the 100th, which is right here, 3.81. And if you remember how to do estimating, you go to the one digit less than when you're trying to round, and if it's greater than or equal to 5, you round up. And if it's less than 5, you leave it as it is. So in this case, it's 0, so it's less than 5. So it's 3.81 is the answer, using the calculator rounded to the 100th. If this was a 3.815, that would have been you'd be going up. You'd be estimating up, and it would be 3.82. But in our case, it's 3.81 to the nearest 100th. Okay, example 4. I have a 4a here, but it's 4. Check your understanding. Go ahead, pause the video, give it a shot. Plug that into your calculator and see what you come up with, and round it to the nearest 100th. Okay, I'm sure you've stopped. If you're going to, you've stopped it and you've returned. So what is the square root of 17.81 to the nearest 100th? Well, I've taken the time to do it ahead of time, and I can tell you I've done it, and I've plugged it into my calculator, and as you see, I've got it estimated as an approximation, in the number of the square root of 17.81 is 4.220189569201 using the calculator. But rounded to the nearest 100th, we're going to go back and we're going to look to the 100th point, which is the second 2 here, tenths, hundredths right here. And then we're going to look to the number preceding that one, which is a 1. And that means it's less than 5, so we don't round up. Okay, so we leave it here. The 0 stays 0. It's a 0 here. There's nothing causing us to raise this up. 0 is certainly less than 5. So to the nearest 100th is 4.22. Okay? And it's an approximate value. Okay, example 5, a real-world problem we're going to solve here. And it's a construction problem. It looks like it's going to be fun. Okay? The formula d equals the square root of x squared plus 2x squared, the quantity 2x squared, gives the length for d for each wire for the tower at the, it says at the left. I'm going to change that. I'm going to change it in the video. I don't have to change it now. It should have said to the right. Sorry about that. I'll change it when I post this. So it says find the length of the wire if x equals 12. So right now we're looking down here at this diagram on the right, not the left. And where'd my pen? Oh, there's my pen. So it says the x value right here is equal to 12 feet. So now we know the x value. We also know the height of the tower, which is 2x. So whatever the height of x is, the width of this post where the wire is tied into the ground is half of the height of the tower. Okay? So let's work the mathematics for it. So we know the formula. They gave it to us. D for the length of the wire is equal to the square root of x squared plus the quantity 2x squared. So filling in the values, we have for the d equals the square root of x squared, we have 12 squared plus 12 times 2 squared. And if you carry out the math, it ends up being the square root of 144 plus 576. You add those two numbers together, and you're going to get 720, the square root of 720. So to the nearest tenth, what is the square root of 720? Well, if you put it in our calculator, we're going to find out that the square root of 720 is 26.8 something. Okay? In fact, I could do it. Let's see. I'll take out my calculator, which you can't see it, but I'm going to say square root of 720, and it equals 26.832. Okay? 26.8, I'm going to write it right here. Where'd it go? Pen. 26.832. Any more? 832, 815. 815. You see how it goes on and on and on. 729, 729, yes, 729, and ending up with 99 something, 99 with a couple 99s. So this goes on forever. But they want it rounded to the nearest tenth. Well, the eighth right here is the 10th spot, and the number before that is a 3, and that's less than 5. So we're going to leave the 8 like it is, and we're going to say that the answer is approximately. And why is it approximately? Because we're throwing away all these numbers. That's not in our answer. We don't know. We didn't include it. If we'd included even every one of these numbers, it would still be approximately, because these numbers go on forever. We'll never know what the true answer is. We cannot calculate it. So the wire is about 26.8 feet long. Okay, example 5, check your understanding. So they're going to give you a turn to go measure the tower and come up with an answer. So suppose the tower is 140 feet tall. How long is the supporting wire? Round to the nearest tenth of a foot. It's basically the same problem, except now they're telling you how tall the tower is and not how far out the stake to pin the wire to the ground is from the center of the tower. So go ahead and do it. Pause the video, and when you come back, we'll look at it together. Okay, now check your understanding. You've gone off and you've solved this problem on your own, and we're going to work it together. So suppose the tower is 140 feet tall. How long is the supporting wire? Round to the nearest 1/10 of a foot. And it says if the tower is 140 feet tall, then the value for x is 1/2 of the 140 feet, or 70 feet. If you look at the tower, you see that the height here, it says is 2x. Well, if the height is 2x, that means x is half of 140, which is 70, down here, 70 and 140. So those are our two values that we're dealing with. So back in the equation, we have the same equation from the previous slide. 70 squared plus 2 times 70 squared is equal to 4,900. 70 squared is 4,900. And 140 squared is 1960. Add the two together and you'll get 24,500. Take the square root of that and you're going to get approximately 156.5 feet. Okay, 156.5 feet. That's the answer. That's rounded to the nearest tenth. If you'd like to do it, I will take it right now, and I will say the square root. The square root of, what was that? 24,500 is 156.524758. Okay, I'll write it right in here. It's this. Where's the pen here? So this is equal to 156.524 758 424 98, and on and on and on and on and on. So we rounded that to the nearest tenth, and we got 156. We went to this point, the 5, and since the next number over to the right is less than 5, this number stays 5. So it's approximately 156.5.